Scientific method is a series of steps followed by scientific investigators to answer specific questions about the natural world. The steps of scientific method are: make an observations, ask a question, form a hypothesis, conduct an experiment, analyze the results, and draw conclusion.
Let's explore the scientific method, which at first might seem a little bit intimidating, but when we walk through it, you'll see that it's actually almost a common sense way of looking at the world and making progress in our understanding of the world and feeling good about that progress of our understanding of the world. So let's just use a tangible example here, and we'll walk through what we could consider the steps of the scientific method. And you'll see different steps articulated in different ways, but they all boil down to the same thing. You observe something about reality, and you say, well, let me try to come up with a reason for why that observation happens, and then you try to test that explanation. It's very important that you come up with explanations that you can test, and then you can see if they're true, and then based on whether they're true, you keep iterating. If it's not true, you try to come up with another explanation. If it is true but it doesn't explain everything, well, once again, you try to explain more of it. So as a tangible example, let's say that you live in I don't know, northern Canada or something, and let's say you live near the beach, but there's also a pond near your house, and you notice that the pond tends to freeze over sooner in the winter than the ocean does. It does that faster, and it even does it at higher temperatures than when the ocean seems to freeze over. So you could view that as your observation. So the first step is you're making an observation. Observation. So you might come up with a more refined testable explanation, or you might come up with more experiments that could get you a better understanding of the difference between fresh and salt water. Or you might try to come up with experiments for why exactly, what is it about the salt that makes this water harder to freeze. So that's essentially the essence of the scientific method. And I want to emphasize, this isn't some, bizarre thing. This is logical reasoning. Make a testable explanation for something that you're observing in the world, and then you test it, and you see if your explanation seems to hold up based on the data from your test. And then whether or not it holds up, you then keep going, and you keep refining, and you keep learning more about the world. And the reason why this is better than just saying, oh, well, look, okay, I see the pond has frozen over and the ocean hasn't. It must be the salt water, and I just feel good about that, is that you can't feel good about that. There's a million different reasons, and you shouldn't just go on your gut. Because at some point, your gut might be right 90% of the time, but that 10% that it's wrong, you're going to be passing on knowledge or assumptions about the world that aren't true. And then other people are going to build on that. And then all of our knowledge is going to be built on kind of a shaky foundation. And so the scientific method ensures that our foundation is strong. And I'll leave you with the gentleman who's often considered to be the father, or one of the fathers, of the scientific method. He lived in Cairo and in what is now Iraq nearly 1,000 or roughly 1,000 years ago. And he was a famous astronomer and physicist and mathematician. And his quote is a pretty powerful one, because I think it even stands today. The duty of the man who investigates the writings of scientists, if learning the truth is his goal, let me start over just so I get the dramatic effect right. The duty of the man who investigates the writings of scientists, if learning the truth is his goal, is to make himself an enemy of all that he reads and attack it from every side. He should also suspect himself as he performs his critical examination of it, so that he may avoid falling into either prejudice or leniency. Hassan ibn al-Haytham, and his Latinized name is Al-Hazan. So he's saying be skeptical, and not just skeptical of what other people write and read, but even of yourself. And another aspect of the scientific method, which is super important, is if someone says they made a hypothesis and they tested and they got a result, in order for that to be a good test, and in order for that to be a good hypothesis, that experiment has to be reproducible. Someone can't say, oh, it was only, a certain time that only happens once every 100 years, and not that's why it happened that day. It has to be reproducible. And reproducible is key, because then another skeptical scientist like yourself can say, let me see if I can reproduce it. Let me not just believe it because that person looks like they're smart and they said that it is true.